All right. So this is going to be day 2 of application of Conics. Again, these are usually the pieces that you guys struggle with because they're word problems and trying to figure out, well, what exactly do I know? What am I given? So let's go ahead, let's break these down as much as we can and hopefully get you guys on the right track on how to do these. So this is going to be for quiz problems. Maybe you'll see the same problem when you take your quiz today. Again, make sure you guys are staying on pace with the calendar. It's different than what is provided in your on your scheduling. So pay attention to how I assign it to you guys. Be aware that I'm still waiting. Supposedly today's the day that they're going to give us the exact details for the state testing. So if you're a junior, I know it's supposed to be between the 18th and 20th. It is going to be mandatory Zoom cameras on while we take the test. You will take the test at a set time. And it'll be ran through your first and second period teachers. So again, more details to come with that. Seniors don't have to worry about it. Last day for seniors is going to be May 20th. So keep that in mind as you guys are working through everything, get everything done by then. Extra credit opportunity. If your notes and you complete the Conics test, which is analytical geometry test by May 17th, it's scheduled for May 17th. Based on my calendar. So if you have them both done by May 17th, then I will give you 5 points extra credit on that test, as well as 5 points towards your final exam. So you'll get 5 points on each of them if you are up to date on May 17th. So that's a good little motivation. All right, so enough announcements. Let's rock and roll. So our first one, I can tell from looking at this that this is going to be a hyperbola. So I'm not even reading the problem yet. I'm just kind of figuring out what am I working with. Since it's x first, since I have my x value first, I know that the hyperbolas are going to be opening up along the direction of my x-axis, so left and right, because the x-axis goes left and right and the x values first. Okay, so it says a castle entrance has walls that can be modeled by this equation with units in feet. How wide is the entrance where the walls are closest together? Okay, so if this is going to model the walls, I want to know how close together the wall or how wide this is. So from where the walls would be, from here's going to represent where one wall is going, here's going to represent where another wall is going. So how wide is the entrance? So they're saying that this right here would be our entrance. So I'm going to kind of redraw this down here. Okay, so here's what I have. This right here is going to represent my a squared is 10 squared, so a is going to be 10, right? This right here, 30 squared is my b squared, so b is going to be 30. So I know then my center is going to be at 0, 0. There's no h or k, so there's my center. So my a, I'm going to count along my x-axis. I'm going to count 10 to the left and 10 to the right. I know that these are going to give me my vertices. These values here, my b, my co-vertices, is going to be here at 30, and this is going to be down to negative 30. Of course, this isn't to scale, but it's just to get an idea of where things are. So I know my parabolas are going to open up like this. There's my hyperbolas. Okay, so this is going to represent the distance or our entrance, the distance between the walls. So this is going to represent our entrance. This 30 up here, though, this right here, this would represent the height of the wall. So just to kind of give you guys some visuals of how to actually put it in context of the castle, so this would be representing that height, and this distance right here between the vertices would be the entrance that they're talking about. It's where the walls would be closest together. So how wide is this entrance? Well, we know that if this is going to be 10 and this is going to be 10, then this entrance has to be a total of 20 feet. And there's my answer. So again, sometimes it's hard to visualize, like how are you getting a hyperbola to go into this format? So they're saying that the wall is representing these hyperbolas going out. The height right here is going to be how high that wall is up. So just some little pieces to help kind of guide you and visualize. All right. My next one. So it says a company produces circular drink coasters. So we're going to be working with a circle. And look, they gave us this equation for a circle with units in inches. So of course we need to pay attention to our units. Remember, I think we had a problem yesterday where they gave it to us in miles, but then we had to convert it to feet. So pay attention. They might give us to it in one and then one answers in another, or there might be some conversion there. So always pay attention. So that represents the size of the coaster. So each coaster is cut from a square piece of cardboard. What is the minimum possible area of each cardboard piece? Okay, so let's have this visual. So we have a circle here. Here's my circle. And it's represented by this equation, x squared plus y squared is equal to 18.0625. So I know that this value right here represents my r squared. So if that's r squared and I take the square root of it, then r is going to be 4.25. So from here to here is going to be 4.25. My diameter then is twice that amount. My diameter is 8.5 and we're working with inches. So the entire length of that circle across the circle, that diameter is 8.5 inches. So I know that whole width there is 8.5 no matter where I go. And this coaster is cut from a square piece of paper. So this square piece of paper looks something like this. So the whole question is, what is the area of this square piece of paper? So let me ask you this. If this across is 8.5, then this length right here has to be what? Yeah, it has to be 8.5 inches and it's square. So I know that across from here, especially because this is a circle, that this diameter is also 8.5. It doesn't matter where I go, my circle across is always going to be 8.5. So that means that this also is going to be 8.5 inches. So if I want to figure out the area, the minimum possible area, the smallest piece, that it has to be at least a length, width, however you want to look at it, of 8.5 for the square piece. That's the smallest it can be. If it's less than 8.5, then we won't have our full circle. So that would be the minimum. So when we want the minimum possible area of each piece of cardboard, the cardboard is a square, so the area of a square is s squared. The minimum length of each side is going to be 8.5, so 8.5 squared is going to be 72.25, and it's always going to be square inches when we talk about area. And so here's my answer right here. If I go too fast or you have any questions, please let me know. All right, Antonio constructs a model of a moon orbiting a planet along the elliptical orbit. A lot of times when we go and use our ellipses, we're usually talking about stuff in space. We were talking about a comet yesterday. So a lot of things in space are moving in that elliptical pattern. So again, I know this is going to be an ellipse because this is going to be a positive there. It's equal to 1, so it's an ellipse when it's a plus and equal to 1. If it was just some value equal to an r squared, that's when we're going to have our circle. So when there was no denominator here, it'd be a circle. So it represents the shape of the orbit. If the planet is located at one of the foci, which phase describes a possible location of the model planet relative to the center? Okay, so again, let's figure out what do we have. So I know that this right here is going to be my a squared. This one's going to be my b squared. So this is my a squared because it's larger. When we talk about an ellipse, a squared is the larger value. So if I look here, my a squared is equal to 342.25. So the square root of 342.25. So A is equal to 18.5. I know my B squared is equal to 325 4. So 324, some of you guys already know, just going to be my 18. But again, I like to kind of work some of the stuff in the calculator for you guys. Oops. Square root 324 is 18. Make sure you're familiar with the calculators too, because on some calculators, I would do the 324 and then my square root, and on this calculator, it's square root and then 324. So all calculators are different. So get familiar with your calculator. So again, this is going to be 18. All right, so what do we have going on here? I have here here's my center at 0, 0. So I have a vertex here at negative 18.5. That's under my x-axis. So that's going along the x-axis then. So it's under my x. It's going to go with the x-axis. This is 18.5. This value was under my y. So it's going to be along my y-axis. So this is 18. This would be my negative 18. And of course, I have my ellipse here. You know, my artwork here is not very good, but you guys always get the idea of what I'm trying to draw. So what are we trying to get? We're looking for, if a plant is located at one of the foci, we're looking to see where the foci is going to be on here. Now remember, the foci are always going to be on my major axis. So it's going from vertex to vertex. So I know it's going to be somewhere left or right of the center. It's going to be somewhere left or right because it has to be on the major axis. So I know it's not going to be above or below. So it can't be either one of those two. So the next piece is, in order to find my foci, we need to know our C. So since this is an ellipse, C squared is equal to A squared minus B squared. So C squared is equal to A squared is 342.25. B squared, it was 324. So this is going to leave me with 18.25. So C squared is 18.25. If I take the square root of 18.25, I get approximately 4.3. We'll round it to 4.3. You can see their numbers around to the tenths. So I know that C is going to be approximately 4.3 then. So it's going to be 4.3 to the left. So at negative 4.3, I would have a foci. And at positive 4.3, I would have a foci. So my option, if I know the value, it's approximately 4.3. And in this case, it's to the right of center is going to be the correct one. So it only gave me this option, so that's my only one. It could have been to the left of center as well. Could have been where my planet was located, but that's not an option, so it has to be here at the right. So again, this would be where my planet is right here. Here's our planet. So it's to the right, 4.3. Alrighty. My next one. Let's see what else we have. Okay. So a company is introducing a new product and they give us this equation. This is not squared. It's a y equals, I only have a squared here with the x. This is an example of a parabola. This is just a parabola. So it predicts the expected profit in thousands of dollars, where X represents the number of thousands of units of products sold by the company. Okay, so this is going to be on my coordinate plane, and here's what I know. Here's what I just read. I haven't even gone to the question yet. But X represents the number of thousands of units sold by the product. So X, my x-axis, is going to be the number of thousands of units sold. This equation predicts the expected profit. This is my y equals. So it's the expected profit in thousands of dollars. So my y-axis is going to be, sorry, I'm going to turn it while I write. This is going to be thousands of dollars profit. Okay, so we're talking money here. This is my y-axis. Okay, so what else do I know? Well, first of all, so this is saying then how many units must be sold to yield a maximum profit? So I need to figure out, what does this parabola look like? What does this parabola look like? So I know since this is a negative and it's a y equals equation. If it's a y equals, it would be a parabola would either open up or down. Since it's a negative, it's going to open down. So I know that I'm going to have some parabola that's going to open downward. Now this isn't to scale, but this is just to give us a visual. So this point up here is our vertex, and we're looking for the maximum profit. When we talk about profit, we're talking about this y-axis. So what is the largest y-axis? So that happens here at our vertex. It happens at our vertex is where we're going to get the max profit, is at our vertex, which we know is our HK value. So the vertex of a parabola is at HK. This right here is the vertex, which is our max profit. So how do I figure out that max profit? Well, I just look at the equation they gave us. Can I identify my H and my K value? So I have y is equal to negative 0.001 x minus 600 squared plus 90. So when you look at it like this is my H and this is my K. This negative is part of it, but maybe you're more familiar with it written this way. Y, where I move my 90 over, minus 90 is equal to, and we kind of put our parentheses like that. Sometimes it's easier for you guys to identify your HK this way. It's equivalent to however you want to look at it. Again, sometimes you guys like looking at it better this way because sometimes you flip the sign, sometimes you keep the sign. In this case, you would flip both signs. So here's my H, here's my K. So my vertex is at 690. Okay, but that's not my answer. So this represents the X is my units sold, and this is my profit. So my profit I have here as 90, but it says how many units must be sold to yield that maximum product or profit. So my maximum profit is at 90. How many units must be sold? So this says 600. So some of you guys go, oh yes, look, 600. But be careful because this 600 represents the thousands of units. So for 1 unit sold, it represents 1,000. So for 1 unit sold, it represents 1,000. So if I have 600 units sold, I would need to multiply that by my 1,000, and I would end up with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I would end up with 600,000 units. So the profit isn't $90, it's 90 times $1,000. So you need to make sure then you would multiply 90 times 1,000 and you would get, so you have your 1, 2, 3, 4, $90,000 would be the profit. Not $90, it would be $90,000. So if I sell 600,000 units, I would make that maximum profit of 90,000. That's what this vertex is representing. So be careful because they'll try to trick you. Notice that the 600 was an answer choice. So you need to pay attention to the units. And my last one. This was similar to that last problem we did yesterday at the end when we were talking about the lightning strike. All right, so the same idea is going to happen with this one. So a pair of radar station motions a path of a helicopter. Station A is located at the origin. So my station A here is at 0, 0. Station B is located 100 miles east. So never eat shredded wheat is how I learned it. My kids learned it differently. Everyone learns that one differently, right? Okay, so if I'm going to go east, east is going to the right. So I'm going to go east to my station B, and it says 100 miles. If I'm going to go 100 miles, this is along my x-axis, and this point right here would be at 100, 0, right? Okay, so east of station A, the difference in the distance from the helicopter to each station is 60 miles. So the difference in the station is 60 miles. So we have some helicopter. Let me just try to draw a helicopter. And then we have our, I know it's not very good. Okay. So we're looking at the distance here. And so it says the distance from the helicopter to each station is 60 miles. Which equation represents the possible location of the helicopter? Okay, so there's some things we need to figure out here. My first thing is that in between these two points, anyone know, remember what these are even representing? Yesterday said that they're always going to represent what? They're not my vertices because these are being connected to a location of something that's going to move around. And there's always going to be that same mutual distance between them. And when we talk about this mutual distance that can be changing, maybe the helicopter is over here, and then there's going to be a connection between the two. And that happens only at our foci. So these have to be our foci. So we talked about this yesterday, that those have to be our foci. So if these are our foci, then directly between these two would be the center of my hyperbola. Luckily, they even gave me this hint that it has to be a hyperbola because they're all minus. So it's the center of my hyperbola. So if this is the center, where is this center going to be? Well, then the center would have to be at half of 100. In between 0 and 100 is going to be 50, so at 50, 0. Why is that important? Because this gives me my, oops, I should have picked a different color. This gives me my C value. So C has to be equal to 50. C has to be equal to 50. C has to be equal to 50. Okay, so if C is equal to 50, then C squared has to be 2,500. Okay, why do I care about any of this? Okay, before I continue, let's look at my answer choices because this is going to help us even eliminate stuff. Okay, so here's what I know. I know that this is my center at 50, 0. So here's my H and my K. If I look here, this is saying that my center is at 100, 0, and that's not the case. So I know it cannot be either one of those two. These two are both saying that my center is at 50, 0. I'm good there. So the next piece of information is, well, what is my A and what is my B? And I can go ahead and I can use this idea of my 60 miles difference with it. And here's another way. So if I do my 60 squared, you could see it's going to be my 36. So that's one way to look at it. So this would be my A squared, and then I can, or if I do it like this, I would, let me rephrase this. Be careful about doing it like this. If I look at this and this is 60 squared, then I would get my 36 as my A. And when I look at these two, I need to remember that C squared is equal to A squared plus B squared. So if I have 36 and I need to add whatever's over here, is that going to equal my value here? And the answer is no, no. It has a difference of 60. It's not saying that the one is 60. So be careful with that. It has a difference of 60. Well, I don't know what they are. And to be honest, the easiest way to go about these is to look at my answer choices and see, this would be my A squared is 900 plus my B squared is 1600 equals my 2500. So it has to be this option. It has to be that option right there. So some of the problems, use your answer choices to help you solve it. Use your answer choices to help you solve it. And this is a great example of that. So you need to make sure that they make sense. So eliminate always what you can. This is basic. You're looking at the center, things you can easily eliminate. Otherwise, these problems are going to get really ugly and complicated, and I want to make it as simple as possible for you guys. If you guys have any questions throughout the day, just make sure to reach out to me, and then we'll start our last section tomorrow. Otherwise, you guys have a great day, and I will talk to you later. Bye. You're welcome. See ya.
Thank you. Bye. Have a nice day.
Bye, Micah. I'll see you. Take care.
Okay, too.